Now, these were all expressions. Expressions do not have equal signs. In our next example, we're going to write each sentence as an equation. Equations do have equal signs. And the word is going to tell us that we have equals. Again, we're using x to represent a number. 8 increased by a number is 12. 8 increased by a number would be 8 plus x, and that's equal to 12. 8 plus x equals 12. 8 increased by a number is 12. Twice a number equals negative 12. Twice a number is 2x. Equals is telling us equals, and then we have negative 12. Twice a number, 2x, equals negative 12. In C, the quotient of twice a number and 12 is equal to 15. The quotient is division. What are we dividing? The quotient of this and this. Twice a number and 12. Twice a number divided by 12 is equal to 15. 2x divided by 12 equals 15. In example 3, we have twice a number plus 3 is the same as the number minus 6. Twice a number plus 3 is 2x plus 3. Is the same as is telling us equals. Equals means is the same as. The number minus 6 would be x minus 6. So if we put that all together, twice a number plus 3 is the same as the number minus 6. 2x plus 3 equals x minus 6. This time we're going to go ahead and we're actually going to find what this unknown number is. So the first step is building our sentence, building our equation. Once we've done that, we want to get the x's all on one side. So let's subtract x from both sides. Subtracting x from both sides and simplifying on the left, 2x minus x is x plus 3. I should say 2x minus x is x, and then we have our plus 3 carried over. On the right, x minus x cancels away, leaving us with just negative 6. So x plus 3 equals negative 6. We want to get the x by itself. So we want to get rid of adding 3. We do that by subtracting 3 from both sides. The 3 minus 3 cancels, leaving us with just x on the left. And then negative 6 minus 3 is negative 9. So when we have twice a number plus 3 is the same as the number minus 6, we have found the number to be negative 9. Okay, so why are we in the PowerPoint presentation? We're in the PowerPoint presentation because of examples like example 4, where we have lots of words to look at. The distance by road from Chicago, Illinois to Los Angeles, California is 1,091 miles more than the distance from Chicago to Boston, Massachusetts. If the total of these two distances is 3,017 miles, find the distance from Chicago to Boston. So we have to let our variable x represent something. And we want it to represent the answer to our question. The question is find the distance from Chicago to Boston. So we're going to let x equal that distance from Chicago to Boston. We're also told that Chicago to LA is 1,091 miles more than Chicago to Boston. So it's 1,091 miles more than X. X plus 1,091 would be the distance from Chicago to Los Angeles. The total of these two distances gives us the total miles. And we're told that the total of these two distances is 3,017. So X is the first distance plus X plus 1,091 equals 3,017. Let's carry this over to the next page. Combine like terms. X plus X is 2X. We have 2X plus 1,091 equals 3,017. We're going to go ahead and subtract the 1,091 from both sides. That leaves us with 2X on the left. 3,017 minus 1,091 is 1,926. Divide both sides by 2 to get rid of the 2 times X. We want the X by itself. So X equals 963. That's 1926 divided by 2. When we're doing word problems, we always are able to check by taking our answer and plugging it back in to the original equation. And if we do plug 963 back in for X, we get 3,017. So it does check. That means the distance from Chicago to Boston is 963 miles. Let's look at another. Example 5, a woman's $57,000 estate is to be divided so that her husband receives twice as much as her son. How much will each receive? So we need to find the answers for both. Since the problem says twice as much as her son, and we don't know what the son is, that means what the son gets is going to be the unknown. We're going to let X equal the son. The husband receives twice as much as the son. Twice as much as X. Twice X, 2X. 2 times X. So we're going to let 2X be the husband. If we add both of these together, we would get the total $57,000. So X plus 2X equals 57,000. Combine like terms on the left. 1X plus 2X is 3X. 3X equals 57,000. To get the X by itself, we need to get rid of multiplying by 3. So we divide both sides by 3. 57,000 divided by 3 is 19,000. If we plug 19,000 back in for X, it does check. We do need to know how much the husband receives as well. So once we know that it checks, 2 times X is the husband. 2 times 19,000 is 38,000. Okay, so that was solving some application problems using algebra. Now let's look specifically at how we would solve percent problems using equations. So recognizing keywords in a percent problem is helpful in writing the problem as an equation. This should be words. 3 key words in the statement of percent problems and their meaning are as follows. So we always want to know in percent problems that of means multiplication. So times. Is means equals, and some form of what will mean the unknown number. So what does this mean? Let's look at an example. Translate to an equation. 15 is what percent of 20? Each of these gives us a different part of the equation. 15 is 15. Remember, is always means equals. What percent is going to be our unknown? We're going to call that n instead of x in this example, but x is perfectly fine as well. Of means multiply, and 20 means 20. So this literally means 15 is what percent of 20? Let's do another. 2.4 is 25% of what number? Now, when we have one of these, the first step is never going to change. The first step is always is becomes equals, of becomes multiplication. Some form of what, in this case, what number, in the last example, it was what percent, is our unknown, is our variable. What number becomes n, and the numbers carry through. Now, when we go on to solve these in future examples, we're going to make another change, and that 25% is going to have to be written as a decimal. It would become 0.25, but we're not there yet. Let's look at another example. Translate to an equation. What number is 50% of 0.6? Go ahead and see if you can do this one. We're not solving for the number, we're just writing it as an equation. So, as always, what number becomes our variable, becomes n. Is means equals, of means multiply. N equals 50% times 0.06, or n equals 0.5 times 0.06. More practice. 3 more. If you want to try these, go ahead, pause, try them on your own, and then play and see what I do. In A, 42% of 50 is what number? 42% times 50 equals n. Of is multiply, is equal. What number is n or x, or any variable you want, actually, because you're building this equation and it doesn't specify in the directions what variable to use, which means it's up to you. But if it had said use n to represent the number, then you would have to use n. If it said use x to represent the number, you would have to use x. B, 15% of what number is 6? Sorry, is 9. Upside down dyslexia. Sure, 15% times n equals 9. Of is multiply. What number is n? Is equals. Everything else, the 15% and the 9 carry through. C, what percent of 150 is 90? What percent becomes n? Of becomes multiply. 150 stays 150. Is becomes equals. 90 stays 90. N times 150 equals 90. Okay. So what number is 45% of 80? We start by making our changes into an algebraic sentence, into an equation. And why is it an equation? Because is means equals, and equals is an equation. If there was no equals, it would be an expression. So what number, n, is equals 45% of multiply 80. 80. Now we're actually going to go ahead and find this number. So remember what I said, 45% now needs to be changed to a decimal. So 45% becomes 0.45. Why do we change it to a decimal? Well, because we need to do math with it. Percents need to be decimals before we can multiply. 0.45 times 80 is 36. So n equals 36. 36 is 45% of 80. %, of what number is 1.2? %, times n equals 1.2 of is multiply is equal. What number is n? First step in solving, take our percent, change it to a decimal. 0.15 times n equals 1.2. And this time, our numbers aren't on the same side. We can't just multiply with the calculator. We have to get n by itself, which means we need to get rid of timesing by 0.15. We get rid of multiplying with dividing. So we divide both sides by 0.15. We get that n is whatever 1.2 divided by 0.15 is, and our calculator tells us that it is 8. We're asked what percent. Now, when we have problems that say what percent, there's one extra thing we're going to have to do at the end of the problem. Remember, when we're doing our work, we change percents to decimals. So at the end, when we get our decimal answer, we're going to have to change that back to a percent. In the other examples, it asked what number. But when it asks what percent, we need to change it back to a percent at the end. So let's not forget that. But up until that new last step, nothing here is different. Step 1, take what we have, translate it. What percent is n? Of is multiply. 35 stays 35, is becomes equals. 21 stays 21. We have n times 35 equals 21. We want to undo multiplying by 35 to get the n by itself. We undo multiplying by 35 with dividing by 35. When we divide 21 by 35, we get 0.6. 0.6 would be the decimal equivalent of our answer, because all the work happens with decimals. So we need to change 0.6 back to a percent. 60% of 35 is 21, not 0.6%. 0.6 is not a percent. It's decimal that we found by doing our work. It's got to change to a percent to answer the question of what percent. For example, wages. 18% of Frank's wages are withheld for income tax. Find the amount withheld from Frank's wages of $3,680 per month. So Frank makes $3,680 per month. Good for Frank. 18% of that gets withheld. So we want to know what 18% of 3,680 is. So when we have a word problem involving percent, the first thing that we have to do is build one of these sentences that we've been working with. In this case, we want to answer the question 18% of 3,680 is what number? Translate. %, times of becomes times 3,680 is becomes equals what number becomes n. We can't do math like that with the percent, so percent becomes decimal. 0.18 times 3,680 equals n. 0.18 times 3,680 is 662.4. So that is our unknown number. $662.40 were held from Frank's wages for income tax, 18%. The principal of Slidell High School counted 31 freshmen absent during a particular day. If this is 4% of the total number of freshmen, how many freshmen are there at Slidell High School? So we want to know 31 is 4% of what total number? And this says method 1. This is a little preview for you that eventually we're going to have a second method of solving these. And we'll get to that. We'll get to that. We're not even halfway done with this presentation. You want to solve this on your own, go ahead. Pause and come back. I'm going to keep going now. Translate into an algebraic sentence, aka an equation. 31 equals 4% times n. Four percent becomes 0.04. We want to get the n by itself. We want to undo multiplying by 0.04. We do that by dividing both sides by 0.04. That gets the n on its own. And the calculator tells us that 31 divided by 0.04 is 775. That means that Since N is the total number of freshmen, there are 775 freshmen in the school. So wages was an example of percent problems. Attendance could be a type of percent problem. But another common percent problem is percent increase, percent decrease. To find the percent of increase, we take the amount of the increase and we divide by the original amount. And then write the answer, the quotient being an answer to a division problem, as a percent. So the amount of the increase divided by the original amount. The average soft drink size has increased from 13.1 ounces to 19.9 ounces over the past 2 decades. Find the percent increase. So first we need the amount of the increase. To find the amount of the increase, we take our big number, we subtract the small number. 19.9 minus 13.1 is 6.8. So the amount of the increase is 6.8. To find the percent of increase, we take the amount and we divide by the original. It has gone from 13.1 to 19.9, which means originally the original number was 13.1. 6.8 divided by 13.1 is 0.5191, blah, 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 blah. Convert that to a percent, we get about 51.9%. So the amount of the increase divided by the original amount. It's the same for percent decrease. The amount of the decrease divided by the original amount. It's always divided by the original amount. Then write our answer as a percent. John Smith decided to decrease the number of calories in his diet from 3,250 to 2,100. 3,250 seems like a lot of calories per day. Just throw that out there. Find the percent decrease. So first, we need the amount of the decrease. Big minus small to find the amount. 3,250 minus 2,100 is 1,150. What do we divide by? We divide by the original amount. And originally, he was eating 3,250 calories. So 1,150 divided by 3,250 is 0.3538, blah, blah, blah. Write that as a percent, 35.4%. Now in the homework problems, it'll tell you round to 1/10 of the percent, for instance. In order to get 1/10 of a percent, we need not just the 2 past the decimal point. That'll tell us whole percent. We need 4, because we need to look at this value 8 to determine that the 3 rounds up to a 4. And we get 35.4%. If it had asked for nearest 100th of a percent, we would need 1 more digit on the decimal to look at to get us to 2 past the decimal point in the percent. Okay, now let's take a look at some examples involving sales tax, commission, and discount. This might look confusing at first, but then you remember I live in a society. I buy things all the time. When I buy things, I pay tax. If I go to a store and I purchase something, the tax I pay is the percentage tax rate times the purchase price. This is real life. So sales tax is the tax rate times the purchase price. And then once I know how much tax I pay, what do I do with it? I add it on to the purchase price to get the total price. Total price is the purchase price plus sales tax. So let's look at these real life examples. A gold and diamond bracelet sells for $1,800, $1,800. Find the total price if the sales tax rate is 6.5%. Okay, so I go into the jewelry store. I see this gold and diamond bracelet. For some reason, I say I want to buy this for $1,800. Okay. They take it to the cash register. They ring it up. The tax rate is 6.5%. So we want to find the sales tax. 6.5% of 1,800 is 6.5% times 1,800. Tax rate times purchase price. 6.5%, decimal goes 2 places to the left. Decimal form of that is 0.065. 0.065 times 1,800, the calculator tells us, is $117. So not only are we buying this $1,800 bracelet, we have to pay $117 in tax. So what's the total price? We add them together. 1,800 plus 117 is $1,917. The total price for the bracelet, $1,917, 1917. Okay, so maybe a bracelet that costs nearly $2,000 isn't something you can relate to. That's a splurge purchase. What if you need to buy a car? This time, the information is given to us in a little bit different of a way. Instead of us finding the sales tax, we are given the sales tax. We want to find the tax rate. So let's let R represent the unknown sales tax rate. Recall that sales tax is the tax rate times the purchase price. Plugging things in, the sales tax is $1,665. The purchase price is $18,500. We want to solve the equation 1665 equals R times 18,500 for R. But take a look at this form. Did we need to remember sales tax equals tax rate times purchase price? That was an easy way to do it. But if we translate this into one of our percent equations, 1665 is what percent of 18,500? We wanted to find the sales tax rate, which is a percent. What percent? What percent of 1,800 is 1665? We could have just set it up using our percent equations. Either way, we end up with this. We need to get the R by itself. We need to undo multiplying by 18,500. So we divide both sides by 18,500. And we get R equals 0.09. Sales tax is always given. Sales tax rates are given as percentages. So we change this back to a percentage. The sales tax rate is 9%. Maybe you've had a job that uses commission, or maybe you're just familiar with how commission works. The commission on a sale equals your commission rate times the amount of your sales. A sales representative for Office Product Copier sold $47,632 worth of copy equipment last month. What is his commission for the month if he's paid a commission of 6.6% of his total sales for the month? So he gets paid a commission of 6.6% on the total sales. So we need to ask ourselves, 6.6% of 47,632 is what? Or we could just plug straight into commission equals commission rate times sales. Either way, we're going to come up with the equation C, or whatever variable you're using, equals 0.066, 6.6% as a decimal, times 47,632. The calculator tells us that is 3,143.712. Why do we need 3 places past the decimal point when money ends with 2 places past the decimal point? It's because we have to look at this third digit to see if we round up the second digit. It's 2. It's not 5 or greater. It does not round up. So $3,143.71 is his commission for the month. So we found the commission. Let's do an example where we get this information and we want to find the commission rate. A salesperson earns $645 for selling $4,300 worth of appliances. Find the commission rate. So we can plug into our commission equals commission rate times sales, letting R represent the unknown commission rate. Or we could look at this and we can say $645 is what percent of 4,300? 645 is what percent of 4,300? It's the same. We want to get R by itself. We want to undo multiplying by 4,300. We do that with dividing by 4,300. Divide both sides by 4,300. Calculator tells us 645 divided by 4,300 is 0.15. As a percent, that would be 15%. Discounts and sales price. Sale price. Again, we live in a society. We go shopping. And when we go shopping, we like sales. We know how sales work. The amount of a discount is the discount rate times the original price. And this is another typo. Don't copy this with a multiplication. This is subtraction. Sale price is the original price minus, not times, minus the amount of the discount. I'm going to fix that right now. You shouldn't even notice. Magic. Fixed. Sale price equals original price minus amount of discount. How did I know that was a mistake? Why didn't I just blindly trust what was on the slide? Again, it's because we live in a society and we shop and we like sales. And if I want to know what the sale price is, I would take the original price and I would subtract the amount of the discount. A $2,000 designer dress is on sale for 30% off. Find the discount and the sale price. So if it's 30% off, I want to know what 30% of 2,000 is. And notice when we plug into amount of discount equals discount rate times original price, it's exactly the same as asking what is 30% of 2,000. To do the math, 30% becomes 0.3. 0.3 times 2,000 is 600. So the amount of the discount is 600. So what's the sale price? 2,000 minus 600. Which is 1,400. A proportion is simply a statement that two ratios or rates are equal. For example, 5/6 equals 10/12. When we have fraction equals fraction, that is a proportion. We would read it just like an analogy. Fancy SAT word there. 5 is to 6 as 10 is to 12 is how we can read a proportion. 5/6 equals 10/12. True statement. As a proportion, we would say 5 is to 6 as 10 is to 12. So let's write this statement as a proportion. 12 diamonds is to 15 rubies, as 4 diamonds is to 5 rubies. The units, in this case diamonds and rubies, must be in the same place on either side of the proportion. 12 is to 15 as 4 is to 5. Diamonds to rubies equals diamonds to rubies. 12 over 15 equals 4 over 5. Now we can write a proportion or anything that looks like a proportion, but that doesn't necessarily mean that the proportion is true. How would we check to see if this is true? Well, in this specific example, we would take cross products. You might have heard the phrase cross multiplying before. And maybe when you were working with multiplying fractions, you mistakenly cross multiplied. Cross multiplication only happens over an equal sign, not a multiplication sign. Diagonally, 12 times 5 would have to be equal to diagonally 15 times 4. We're multiplying in a cross multiplication, cross multiplying. 12 times 5 is 60, 15 times 4 is 60. The cross products are the same. It's a true proportion. Now, that might have been confusing. This next slide is going to hopefully clear up what I just did. If we have A over B equals C over D, we can check whether that proportion is true by taking cross products. A times D diagonally, B times C diagonally. If they are the same, the proportion is true. If they are not the same, the proportion is false. So, is 3 over 6 equals 4 over 8 a true proportion? Is it true that 3 is to 6 as 4 is to 8? Those both reduce to 1/2, so we suspect strongly that it is true. But using cross products, 8 times 3, 6 times 4, both of these are 24. The cross products are the same. The proportion is true. Now, you might be asking yourselves, Mr. John, Professor Wilbruna Mayhew, those were both clearly 1/2. Can we always just reduce the fractions and see if they're the same? Yeah, you can. If it's something that's easily reducible. What about here in example 3? 4.1 over 7, 2.9 over 5. Those aren't fractions that we can easily or clearly reduce. So cross products is always the way to go because it'll get you your answer every time. So cross producting this, 5 times 4.1, 7 times 2.9. They're close. 4.1 times 5 is 20.5. 2.9 times 7 is 20.3. They are close, but no cigar. They are not the same. It is not a true proportion. The proportion is false. Now that we know we can check proportions to be true by looking for the cross products and seeing if the cross products are equal, we can use a similar method to set up and solve for missing or unknown numbers in proportions. Step 1, find the cross products and set them equal to each other. Step 2, divide the number not multiplied by n by the number multiplied by n. Now, you may have noticed the lack of word problems in the course before now. Originally, the order of the textbook, this is supposed to come before we learned algebra, but we know algebra now. We know how to solve for n, and that's all step 2 is saying here. It's saying get n by itself by dividing by the number multiplied by n. You'll see. It's just algebra. Find the value of the unknown number n. We want to take our cross products and set them equal to each other. 51 times n equals 34 times 3. 51 times n equals 34 times 3. 34 times 3 is 102. How do we get n by itself? How do we undo multiplying by 51? We divide both sides by 51. And 102 divided by 51 is 2. The unknown number is 2. Find the value of the unknown number n. Again, just take the cross products and set them equal to each other. 1.2 times n equals 6 times 0.7. 6 times 0.7 is 4.2. Divide both sides by 1.2 to get the n by itself. 4.2 divided by 1.2 is 3.5. So apologies in advance, example 7. If you want to try this on your own, feel free, pause. See if you remember how to multiply mixed numbers. I'm going to continue. You're doing great. We only have 12 more slides. This is slide 52 of 64. So hang in there. Relatively speaking, we're almost done. Take the cross products. 1 2/3 times 2 3/5 equals 3 1/4 times n. In order to multiply with mixed numbers, we need to change everything to an improper fraction. So 3 times 1 is 3 plus 2 is 5/3. 5 times 2 is 10 plus 3 is 13/5. 4 times 3 is 12 plus 1 is 13/4. So 5/3 times 13/5 equals 13/4 times n. To multiply 5/3 times 13/5, the 5's cancel. We're left with 13/3. 13/3 equals 13/4 times n. Let's do the rest on the other side of the slide. We want to get the n by itself. We want to undo multiplying by 13/4. We undo multiplying by 13/4 with dividing both sides by 13/4. That gets the n by itself on the right. On the left, we have 13/3 divided by 13/4. Dividing by a fraction is the same as multiplying by its reciprocal. So 13/3 times 4/13. To multiply 13/3 times 4/13, the 13 on the top cancels with 13 on the bottom. We are left with 4/3 equals n. And since all the other parts of the proportion were given as mixed numbers, we change 4/3 to 1 1/3. Now that we know how to work with proportions, let's take a look at proportions and problem solving. This is going to require us to read through a word problem, use the information to set up a proportion where one of the four pieces is an unknown, is a variable, and then solve the proportion for the missing number. Example 1. On an architect's blueprint, 1 inch corresponds to 4 feet. How long is a wall represented by a 4 1/4 inch line on the blueprint? Let's put inches on the top and feet on the bottom. 1/2 of our proportion comes from the first sentence. 1 inch is to 4 feet. So how do we figure out what goes on the right and in which order? Well, on the left, we put 1 inch on the top, 4 feet on the bottom. That means inches are on the top and feet are on the bottom. 4 1/4 inch, therefore, would go on the top. How long is the wall is going to be in feet, and we don't know. It's X, it's unknown. It goes on the bottom. How do we solve this? Cross products. 4 times 4 1/4 equals X times 1, or just X. So X equals 4 times 4 1/4. 4 1/4. 4 times 4 is 16, plus 1 is 17/4. 17/4 times 4 would be 4 over 1. The 4's cancel. 17 over 1 is just 17. We need to make sure we answer the question. How long is the wall? 17. What seemed off about that? 17 what? Well, the number on the bottom of the proportion is in feet. So the wall is 17 feet long. That should say dose, not two. Dose, like in medicine, D-O-S-E, not D-O-E-S. The standard dose of an antibiotic is 3 cc's for every 50 pounds of body weight. At this rate, find the standard dose, correct here, for a 130-pound woman. So the first sentence gives us the first half of our proportion. 3 cc's per 50 pounds. So it's going to be cc's per pound on both sides. We're given 3 cc's for 50 pounds. We want to know the unknown number of cc's for a 130-pound woman. So 3 is to 50 as unknown is to 130. Cross products. 3 times 130 equals 50 times n. Doing the math, 3 times 130 is 390, equals 50n. Divide both sides by 50. Leaves us with just n on the right. 390 divided by 50 is 7.8. 7.8 what? It was on the top. That's cc's. The standard dose for a 130-pound woman is 7.8 cc's. Okay, so that's proportions. Now, method 2 for solving percent problems will be with proportions. There is a percent proportion. Amount is to base as percent is to 100. The percent number always is written over 100 because, for instance, 30% is the fraction 30 over 100. Base is going to be the number that comes after the word of. So whatever of something, that something goes on the bottom. %35 of what number is 28? 35% of what number is 28? Well, 35% is our percent. They really couldn't have moved that box so that word fit on one line. Okay, that's fine. Percent. Of what number? Since what number comes after of, that is the base. Base always appears after the word of. Which means that leftover number 28, that's the amount. The part compared to the whole. $28 over our unknown base is 35 over 100, 35%, percent per 100. And eventually, we would just go on to solve this proportion. $120 is what percent of 360? 120 is what percent of 360? We're setting up the proportion. 120 is the amount. It does not come after of. It's not the base. 360 would be the base. The percent is unknown here. Like I said, 360 is the base because it comes after the word of. Amount over base equals percent over 100. Now, if we were going on to solve this, when we used method 1, when we put it in an equation form, the equation got solved with decimals. And when we found our decimal, we had to change it back to a percent. The percentage itself in the proportion is represented by the fact that it is always over 100. So when we use method 2 to solve, when we solve this proportion, our answer is already the percent. We don't have to do any changes this way. So when we do an example like this, we'll see that we're given the percentage when we find our answer. We don't have to make the change from decimal to percent. Translate to a proportion one more time. If you want to try this on your own, go ahead. Pause. Come back. I'm going to continue. What number is 95% of 75? What number, the unknown, is the amount? the part compared to the whole. "95 is the percent. 75 is the base. Why is it the base? Because it appears after the word of. Now, maybe you're having trouble finding that this is the amount. My strategy is always find the percent and the base. Those are easy to find. The percent comes with the percent sign. The base comes after the word of. The amount then is always the other thing, the thing that's left over. So the amount is always easiest to find last. But we set up our proportion. Amount over base equals percent over 100. Example 4. What number is 60% of 55? What number is 60% of 55? 60% is going to be the percent. 55 is going to be the base because it comes after of, which means what number, the unknown, has to be the amount. And like I said, 60 is the percent, 55 is the base. If you want to set this up, this time we're going to solve for it. So keep that in mind if you're pausing and continuing. Amount over base equals percent number over 100. Now these numbers are huge. 60 times 55 is a big number. But we could reduce 60 over 100. There's no problem reducing this fraction. That is allowed. That would be 6/10. That would be 3/5. Smaller numbers are more manageable to work with, especially if you're doing it by hand. Remember, if this is a test problem, you wouldn't be able to use the calculator, so you would want your numbers to be as nice as possible. Cross products. A times 5 equals 3 times 55. 55 times 3 is 165. We want to get the A by itself. We need to undo multiplying by 5. We divide both sides by 5. And 165 divided by 5 is 33. Thus, 33 is 60% of 55. Example 5. 45% of what number is 36? 45% of what number is 36? What comes after of? What number? The unknown. So the unknown is the base. 45 is the percent. What's left over is the 36. That must be the amount. Amount over base, 36 over B equals 45 over 100. We can reduce 45 over 100 to 9/20. Cross products, 36 times 20 equals 9 times B. 36 times 20 is 720. We want to get rid of multiplying by 9. We do that by dividing both sides by 9. And we get B is 80. Thus, 45% of 80 is 36. Last slide. What percent of 120 is 78? The unknown this time is the percent of 120. So 120 is the base. The leftover is 78. That must be the amount. Amount over base equals percent over 100. 78 over 120 equals P, the unknown, over 100. So this is what I was warning you about before. If we were solving this with the equation x times 120 equals 78, we'd solve for x. It'd be in decimal form. We would have to change that to a percent. When we're doing the proportion, the percent is already a percent because of the fact that it's over 100. So no changes are necessary once we find P. Once we find P, that is the percent. We can reduce 78 over 120 to 13/20. Cross multiply. 100 times 13 equals 20 times P. 1300 equals 20 times P. We divide both sides by 20. I don't know why, but when I'm saying I divide both sides by 20, I'm picturing The Rock about to do the people's elbow, doing that pointy thing that he does, out and in. If you're a wrestling fan, you know exactly what I'm talking about. If you're not, please ignore me. We want to get rid of that. Divide both sides by 20. 1300 divided by 20 is 65. So 65%, no changes needed, of 120 is 78.